Alrighty. Hello everyone, this is the 4th class, and today we'll be going over tables. I'm going to be going through this because I forgot to record last time, so that's why this has been delayed. I forgot to record and I just kept getting lazy. So I'll be going over tables. And last time in class I explained basically what tables were, and I used this kind of like analogy, well, not really analogy, but kind of like this method of thinking of what tables are. So inside of tables, they're kind of just like creating a variable. So you can see I typed that all out really quickly, but these brackets, I don't know what squiggly lines people usually call them. I don't remember what they're called, but they are basically what's going to be your table. And you'll be like, okay, what the hell am I looking at? So how I like to think of tables as is a suitcase, briefcase, anything that can contain something in it. Your table is basically a container. It can hold objects in it. And the variables I taught in the beginning class is what's going to be going inside of your suitcase or briefcase, which is your table. So if we were to put something like hello, now we have a variable in our table. Now if we wanted to add another one, we'd be like, okay, now we have a string and an integer in our table. And now you could keep adding stuff over and over and over like that, and you can make your table bigger and bigger. And now you might be like, okay, we have things in our table, how do we access them? How do we know where they are? So in a table, there's something called the increment and value. Now it's not shown until you ask for it. However, what we know is that increment starts at 1 in Lua. In other languages, it starts at 0. In this language, it starts at 1. So this is our beginning. This is not 0, this is 1. So hello's value, we're just going to call it hello, but this value of this string is hello. And the increment is 1. The value of this integer right here is 1, 2, 3, and the increment is 2. Hello is 3, and the value is hello. But the other strings 4, 5, the values D and A, well, D and then A. That's how we look at it. So with this thinking, how we access a table, let's just print the table actually first. Let's see what it prints. Okay, we have these dots. So we have to click open to see the table. We see 1 and the value, 2 and the value, 3 and the value, and so forth. Now, how do we access a certain point within the table? Like I said, we're going to be using another form of these brackets. So what this do is basically you're going into the table. So imagine this as like table inside. So A, our table, and then we want to go inside of it. But what do we put in here? We put in a number. So now what the number signifies is this, is the increment within the table. So if we were to put a 1, we'd get hello. If we were to put a 3, we'd also get the smaller case hello, because that is the value within the table it is. So we can find it through that. Now, how do we remove and add things to a table? So let's actually bring back our table A. We can name our table anything. That could be our table name. We usually just call it like my table. It's just like setting up a variable. It's no different than that. You're just giving it multiple things inside. You might be confused. Why is there no, like, why is local A not hello? And then why don't we like that? You could just put things inside the table without defining what it is, or assigning a variable to it, because you're defining what it is by doing the quotations mark for strings, integers for numbers, and so forth. You could put booleans in here. You could put almost any kind of variable. You could, I don't think you could put a table. You could put it, you just use a dictionary at that point, but I'm not gonna get into that. But that's the stuff you could do with a table just alone. Now, to get into what tables are, there is a library of functions that you can do with a table. So table dot, if you type table dot, you'll see all these things. What I'll go over is insert, find, and remove. Clear is kind of obvious. It just removes everything from the table. But I'll go over them. So table.insert. So if we click in here, we can see that there's insert A and value. Now, what this means is just, the squiggly line just means it's a bracket. A is just a placeholder. T is table, so you can see T. That's like, it's like a value check for if it's a table. So that's all it really does. So you can kind of ignore, it's kind of like jargon. That's basically what this is. You don't really need to know this stuff to be able to do it. It's just asking for the table value first, which is my table. And then we're going to input a value into the table. And now do note, when we insert this value into the table, so we could print it twice, my table, it's going to go to the end. So if we were to add something, it adds on to the end of it. It's not going to go in front, so do note that when you do that. So we're going to add probably like, let's add a number. Let's add 12. Let's see how it changes. So now we can see 5 is the max number and 6. And then we can see 6 has 12 as its value. So the increment 6 in the table has 12 as its value. And do remember, programming is individualistic until you do, what's it called? Until you like make it go double. So I can't remember the terms for that because it's been too long since I've like done split programming. But basically what it's doing is it just reads down the line. All you're doing is just going 1, this is my table, 2, skip, 3, print table, so it prints without the table insert. So just remember, programming uses one line at a time. So if I were to print this here and this here, we'd never see the table insert. We would never see the changes. So just remember, you're reading top to bottom. So whenever you're programming. So if you ever have like an error, you'll probably realize that you might have just done something ahead of it. Now for table.remove. Remove my table. So what this is asking for is the table and the position. So what is the position? The position is the increment. Position increment, they're kind of interchangeable. I call it the increment because that's the position where you are in the table. So if we want to remove, let's say 1, 2, 3. We could do, so 1, 2, that's the position in the table for 1, 2, 3. Let's see it. Now we have both of those. You can see 1, 2, 3 is still present, and then if we look down here, 1, 2, 3 is gone and it's been replaced. So it kind of just, it cuts it in half and it moves the table up. So 4 and 5 have now become 3 and 4. Now let's do table.find. So table.find is something utilized if you have like, say your table's like crazy massive and you're like, okay, I want to find something in it. So you can do table.find. Your haystack, I don't know why they always use these random terms, but the haystack is just the table. The haystack is basically, you're finding a pin in a haystack, or a needle in a haystack is a term. That's why it's called that. But we need a string and a number. Now I don't know exactly what that is, but turns the index of the first. Let's see how that actually works. Table.find. Oh, okay. All right. I see how it works. So we could look for a object. So if we had a bunch of stuff, so if we wanted to just look for D, let's print this and see what happens. It's missing something. Oh, okay, never mind. It is missing, so let's see what happens. 4. Okay. So all that does, it's basically finds where the position in the table of D is. So that's table.find. We learned table.remove. And if we just wanted to clear the table, my table dot. Oh, sorry. Table.clear my table. My table. And then print my table. You're just clearing it. It just yeah, that's what an empty table looks like down here. It's just the brackets. Now we're gonna get to the more advanced stuff. We're going to be going on to looking through at tables. So let's bring back my table. Actually, I keep deleting it. This is where we learn loops. Well, we learned loops, but to go into loops more. For IV in pairs, 2. Now, you're like, what the hell? 4 IV in pairs? What the hell does that even mean? So, while true do loop also applies. So this is kind of like a while true. So I'm going to go bit by bit. For increment in variable, pairs is, let's type it. Pairs is returns an iterative function. Now this looks insane. All pairs does is you put in a table and it goes through the table. And I'm going to go through it with you guys to explain it better to you. So I and V is why I say increment, is because increment is just position in this. So for I and V. So if we were to do for I and V of my table, which is from line 5 to 9, it reads all this over and over per the amount of times that's in this table. So we'll go for 1 in value, which is hello. So 1 hello in my table do. We're going to run whatever. So if we print IV, so for the first increment, print IV. 1 hello. For 2, 1 2 3. For 3, hello. For 4, D. For 5, A. That's all it's doing. I is the increment. So 1 2 3 4 5. V is the variable or value of what the increment is at, or the position in the table. So that's all it does. It just reads tables. It's basically, you're telling it to like read what's in like a suitcase. So say you have a bunch of laundry. This is a shirt. This is where the position in the suitcase it is. That's all it does. So if you wanted other code like to count up, like local, oh no, it's just gonna reset it. Local count equals 0. Count equals plus 1. I think I did that right. And then print count. You're gonna see it run through 1 2 3 4 5. We have 5 things. But the reason why we didn't do that, because the table already accounts for the number it's at, which is with I, the increment within the table. So if we just print I and V, we can see it goes to individually. See how they're not all one line connected? It's 1 2. Like these are different prints at different intervals in time, because it goes from top to bottom. It goes for the first table increment, it goes through this line. It goes through 5 to 10, and then it moves down to the second one. So now the value was now 2 to 1 2 3, and then 3 hello. So it reads everything in here, and then it moves to the next iteration within the table. So that's how the for IV in pairs works. So that's some stuff we could do with it. If you want, I'll show you something advanced real quickly. So if we want to get the, we'll move this to a local script. And local scripts are kind of just like mainly focusing on the player alone. Or like client side. So local player equals player. Oh, game dot players dot local player. Local character equals player dot local character. Oh, that. Oh, I already got that. Okay. Or this is just safety checks that I do. It's just a habit. It's best practice too. So the character here, we have the character model right here. So print, okay, so for IV in pairs, character get children, and I'll explain this all in a bit. Print IV. Let's see if this actually works. Okay, so you're probably like, what the hell? How did you get this table? So how I made the character into a table is with get children, and I'm gonna explain what get children does. So let's go to my character. So this is the character that we got from this. See, right now it's just a single instance, but if we open it up, we could see that there's a bunch of things within there. So that's how the character and parents work. Get children is just getting the lower elements. So if I click the drop down, the children is just everything in this. This is all the children. The parent of these children is my character, and the parent of my character is the workspace. and then the game is the true parent. So that's why I went game.players.local player, which the local player is me in this local script. But like, what can we do with this for IV in pairs? What we can do is we can look for stuff within the characters get children. So now that we have access to all this stuff, if V is a base part, now this is kind of like advanced, not really advanced, more basic stuff. But is a is just, it just finds a, what's it called? Oh fuck. Let's spawn a part. Okay, I accidentally spawned that in there. We spawn a part, and we look at the class. It is a part. So base part is mesh part, any other type of part. That's what a base part is. That's why you say it. Print v.name, and we will see this. And we can print I for see how many times it goes through. So it runs through everything, and like, okay. So it doesn't print the name for this part, so they're not base parts. And then we find, okay, the head is a base part, left lower leg. It goes through all the R15, even the humanoid root part. And it finds everything that's a base part within the character. That's all is a does. This is just an if statement that if it's true, it will run this. And if the part is a base part, which V is, so V in there, as we can see as it goes through the table of the character, which is the 4IV in pairs, we can see it prints I, which is the increment, V, which is the value of the current increment within the table. So we can see the head and then the rest of this stuff. But that's basically what you could do with tables. There's so much more stuff you could do. You can make up, you can have like your own tables that you make. So you can make like, you can make let me just play it. And then you can make like your own body parts. Head, body, torso. But they won't be in the, you won't physically see them, of course, because it's just code right now. It's just lines of code that don't actually replicate or become a physical thing until you make it. But that's like a hypothetical body you can make. Like, you can make stuff like that, iterate through it. I don't know why I said body and torso, even though they're kind of the same thing. Well, no, the body's the whole thing. But, like, that's the things you could do. And then you can go through car. Oh, it doesn't have a get children because it's not a property of the workspace. But you could just print IV. And now we have our little table. I'm just going to print 1, 2, 3, 4, 1, 2, 3, and then all the stuff. So that's what you can do with tables. There's so much more advanced stuff. There's infinite possibilities. But we're probably going to go more advanced stuff from now on. I tried giving you guys a bit of, like, a dip of what you could do in actual Roblox rather than more OOP scripting. Or not scripting, but just programming in general. I wanted to get your basics strong. But I wanted to give you, like, a taste of what you can do actually within the Roblox Studio itself, rather than just showing you lines of code and actually giving you a chance to understand interactions of code to client not only and server, but just a bit of things. But that's all. Thank you.